Imagine an entire city floating in the middle of the ocean, capable of launching squadrons of jets, commanding naval warfare, and sustaining itself for decades without refueling. This is the USS Gerald R. Ford, the new cornerstone of the U.S. Navy's maritime power. At 337 meters long, making it one of the largest warships in the world, with a displacement of 100,000 tons and a crew of 4,500 people, it is not just a ship. It is a mobile arsenal with the reach and power projection capability of an entire continent. But what truly makes it revolutionary is not just its colossal size, but its design philosophy, reimagined for the unpredictable and complex threats of the 21st century. While previous aircraft carriers, such as the venerable Nimitz class, were built for the wars of the 20th century, based on steam and hydraulic systems, the Ford is specifically designed for the modern digital combat scenario. It is stealthy, intelligent, and ready for the future, harnessing the massive power of a nuclear core and an advanced electrical infrastructure to transform every system into an intelligent and efficient component. In an era of autonomous drones, cyber warfare, and hypersonic missiles, the Ford is not just part of the game. It is the arena where the future of naval warfare will be decided. Its true secret lies in the fusion of steel and fiber optic circuits, making it less a ship and more a digital fortress at sea, capable of adapting and responding to any challenge with data processing speed. The hull design, while maintaining the silhouette of an aircraft carrier, incorporates stealth elements such as the repositioning of the island and the reduction of the radar cross-section (RCS), making it more difficult to detect and track by modern surveillance systems. This is the first time an American aircraft carrier has been designed from the outset with stealth considerations. The island superstructure, for example, is smaller and more angled, and the ship uses radar-absorbing coatings in certain areas. Want to discover more secrets about the Gerald R. Ford? Subscribe to the channel so you don't miss any in-depth analysis of the most advanced military technology. The Ford incorporates a culture of unprecedented automation and efficiency, breaking with centuries-old Navy traditions. Digitization and adaptability now define naval vessels. Instead of just following the battle, the Ford anticipates and dominates it, and this fundamentally changes naval doctrine. Its ability to process terabytes of data in real time, make AI-assisted decisions, and neutralize emerging threats makes it an invaluable asset and a force multiplier. The Ford represents a paradigm shift, from an aircraft launch platform to a floating network command and control center, C5ISR. The USS Ford is the embodiment of the Navy's innovation and strategic vision, a ship that not only adapts to the future, but actively shapes it, setting a new standard for global power projection and interoperability with allied forces. Its presence in any theater of operations sends an unequivocal message of power and determination, acting as a key element in U.S. defense diplomacy. The onboard systems are interconnected by a high-speed fiber optic network, allowing instantaneous exchange of information between the flight deck, the command island, and the combat centers, ensuring superior situational awareness. The USS Ford is not just big. It is a marvel of logistics and naval architecture, housing 17 decks, 5 acres, about 20,000 square meters, of flight deck, the equivalent of 4 American football fields, 2 state-of-the-art A-1B nuclear reactors, and over 3 million meters of cabling. It is a fully functional floating metropolis. The A-1B reactors are the heart of this revolution, providing 3 times more electrical power than the reactors on Nimitz-class aircraft carriers. This power generation capacity is crucial for powering new electromagnetic systems, such as EMALS and AAG, and for accommodating future directed energy weapons, such as lasers and electromagnetic railguns, ensuring the ship remains relevant for decades. Life aboard is designed to optimize crew morale and readiness. In addition to fitness centers, hospitals, and cafeterias, The Ford has wider recreation areas and an improved accommodation design, with more comfortable bunks and more modern living areas. The crew, although smaller, benefits from a more habitable and efficient environment. All this just meters away from a RIM 162 evolved Sea Sparrow missile launcher and the sophisticated Phalanx CIWS point defense system. This comprehensive infrastructure not only ensures that the crew can maintain a high level of morale and readiness, but also transforms the ship into a truly self-sufficient and resilient community, capable of operating independently for long periods in any theater of operations, from the warm waters of the Persian Gulf to the cold of the Arctic. This pursuit of operational efficiency required precision engineering at every level. Two notable advances are the EMALS, electromagnetic aircraft launch system, and the side hangar elevators. EMALS, in particular, is a game-changer. It replaces the old, complex steam catapults, which relied on fresh water and were limited in their launch capacity, with a linear magnet system that accelerates aircraft more smoothly and with greater precision. The principle is simple. The massive electrical power from the A1B reactor is converted into a moving electromagnetic field that propels the catapult car. This allows the launch of a wider range of aircraft, from heavy FA-18EF and F-35C fighters to light and heavy drones, and increases the aircraft's sortie rate by up to 33% compared to the Nimitz class, minimizing downtime and structural stress on the aircraft. The side elevators, in turn, are designed to move jets vertically out of the service lanes with speed and safety, using linear motors that are faster and more reliable than traditional cable and hydraulic systems. The Ford has 3 of these elevators, compared to the 4 of the Nimitz class, but their speed and load capacity are superior, allowing weapons to reach the flight deck 50% faster. These features, while they may seem like technical details, are the essence of the Ford's ability to sustain an unprecedented pace of air operations, ensuring that air power is always ready for action. Both innovations transform the Ford's deck from a crowded and dangerous runway into a continuous and fluid operating zone, ready for today's jets and tomorrow's unmanned aerial systems, UAS, including the future MQ-25 Stingray, which will be crucial for aerial refueling and extending the strike group's range. The EMALS launch capability allows the Ford to launch an aircraft every 45 seconds, a significant increase over the steam system. The ability to operate aircraft so fluidly and efficiently is a testament to the advanced engineering and meticulous planning that went into the USS Ford's design. It is not just an aircraft carrier. It is an adaptable and multifunctional air platform, capable of continuously integrating new technologies through software and hardware updates, and quickly responding to the demands of an ever-evolving combat scenario. The Ford's flight deck is a microcosm of its design philosophy: maximum optimization, adaptability, and an unwavering readiness for the future of warfare, where reaction speed and operational sustainability will be decisive factors. Its open systems architecture allows for the rapid integration of new sensors and weapons, ensuring the ship does not become obsolete. The flight deck layout, with the repositioned island, allows for 4 launch stations instead of 3, which directly contributes to the higher sortie rate. Imagine conducting 200 sorties per day from a platform moving at 30 knots, about 56 km/h, in the middle of a rough ocean. Supersonic FA-18 Super Hornet and F-35C Lighting Tow. Jets roaring to land at 240 km/h, while others take off in the middle of the deck. This is life aboard the USS Gerald R. Ford, a choreography of kinetic power and millisecond timing, where coordination is everything and a slip can become a catastrophe. But make no mistake, this is not chaos. It is controlled chaos, a masterpiece of coordination and technology that allows the Ford to operate with unprecedented efficiency. Behind every launch and recovery is sophisticated deck management software that integrates radar, weather, ammunition, and fuel system data in real time, providing flight control officers with a 360-degree view of the situation, allowing for split-second decisions. The enhanced ammunition management system also contributes, using advanced electromagnetic weapon elevators that move by electromagnetic induction, transporting bombs and missiles from the depot to the flight deck with greater speed and safety, eliminating the risks associated with traditional cables and pulleys. The Ford can store up to 2,500 tons of ammunition, ensuring the sustainability of combat operations. The crews operate like elite athletes, synchronized to the second. Refuel, rearm, taxi, launch, and redeploy in a deadly cycle of efficiency. Automation and artificial intelligence play a crucial role, not only optimizing every step of the process, but also predicting failures, diagnosing maintenance problems, and minimizing human error. For example, AI can analyze flight patterns and weather conditions to suggest the most efficient launch sequence, maximizing the sortie rate and reducing risk. The ability to manage such a large volume of air operations with precision and safety is what sets the USS Ford apart from its predecessors, making it a truly revolutionary combat platform. The reduction of 600 crew members compared to the Nimitz class is a direct testament to the effectiveness of this automation, freeing up personnel for more critical and strategic functions, such as operating new combat systems and cyber monitoring. If you are enjoying this in-depth analysis, leave a comment below about which Ford technology you find the most impressive. The result of this cutting-edge engineering is a 33% higher sortie rate than any previous aircraft carrier. This is the essence of modern warfare engineering: reduce friction, increase speed, and shift the balance of power in seconds. The USS Ford is not just a ship. It is an integrated and intelligent weapon system where cutting-edge technology and human training combine to create an unstoppable and self-sustaining force. Its ability to generate such a large volume of air, power continuously and sustainably, is what makes it an invaluable strategic asset for the U.S. Navy, and a symbol of its ability to project power anywhere in the world. The Ford is the pinnacle of American naval engineering, designed to dominate the oceans for more than half a century, acting as the main platform for U.S. power projection. Want to understand how technology changes the game in defense and global power projection? Like this video and share it, so more people can learn about the incredible history and future of the USS Gerald R. Ford. Below the flight deck lies the technological watershed, the EMALS, electromagnetic aircraft launch system. Instead of relying on pressurized steam, which is inherently inefficient, dangerous, and difficult to control, EMALS uses electromagnetic force. Imagine the precision and power of a maglev bullet train applied to aircraft launching. The system consists of a linear induction motor that uses pulses of electricity to generate a moving magnetic field, propelling the catapult car. This allows for smoother and more controlled acceleration, which reduces structural wear on aircraft by up to 30%, significantly extending their lifespan. Furthermore, the system is capable of adjusting the launch force for each type of aircraft, from the heaviest fighter to the lightest drone, something impossible with old steam catapults. This flexibility is vital for the future integration of unmanned aerial vehicles, UAVs, and for maintaining air superiority, allowing the Ford to adapt to changes in the air wing composition. The aircraft recovery system, the AAG, Advanced Arresting Gear, is also electromagnetic and works in conjunction with EMALS. It replaces complex hydraulic systems with computer-controlled linear induction motors. Electro-hydraulic dampers absorb most of the landing energy, while the remaining energy is converted into electricity and returned to the ship's systems, an unprecedented energy efficiency feature in an aircraft carrier. The computerized control of the AAG constantly monitors the tension and unwinding of the arrestor wire, ensuring safer and smoother landings, even in adverse weather conditions or if the aircraft touches down slightly off-center. This real-time, adaptive capability is crucial for the safety and efficiency of landing operations, allowing the system to respond to unexpected variations in the aircraft's touchdown, increasing the margin of safety for pilots and reducing downtime, and the risk of accidents. The AAG is designed to handle a wider range of landing weight and speed than the previous system, which is essential for heavier aircraft and for the integration of drones. The USS Ford's Island is more than a navigation tower. It is a compact and highly integrated command center. Positioned 42 meters further aft and 1.5 meters higher than on Nimitz-class aircraft carriers, the island frees up valuable space on the flight deck for aircraft maintenance and movement, and improves wind flow over the deck, crucial for air operations. This strategic relocation is not just a matter of visual design. It is a functional optimization that increases the safety and efficiency of air operations, allowing aircraft to operate with greater freedom and fewer restrictions. The shape of the island also incorporates stealth design elements, further reducing the ship's radar signature, a subtle but crucial detail for survival in a high-threat environment where early detection is critical. The island also houses the dual-band active electronically scanned array, AESA radar, one of the most advanced radar systems in the world. Inside the island, the dual-band active electronically scanned array, AESA radar system, along with 3D, sensor arrays, and artificial intelligence, AI, assisted systems, coordinates all operations, from air traffic control and anti-missile defense to secure communications and cyber monitoring. The AESA radar, in particular, provides tracking and engagement of air and surface targets with unprecedented precision, allowing the Ford to act as an air command and control center. The simplified island design houses multifunctional consoles and augmented reality overlays, allowing operators to process complex threats with minimal latency. The fusion of data from multiple sensors and the intuitive presentation of this information to operators are crucial for quick and effective decision-making in a dynamic and saturated combat environment. Artificial intelligence acts as a cognitive force multiplier, assisting in threat identification, resource allocation, and response optimization in fractions of a second. In essence, the Ford's Island is more like a distributed nerve center than a control tower. It sees, decides, and acts with a speed and precision that redefine naval warfare in the 21st century. The Ford's data processing capacity is estimated to be 10 times greater than that of a Nimitz-class aircraft carrier. The Ford is a giant, but a giant that was built to be cheaper to operate in the long term. Automation and efficient design reduced the necessary crew by about 600 people compared to the Nimitz class. This translates into estimated operational savings of $5 billion to $6 billion over the ship's 50-year lifespan, offsetting the high initial cost. This cost saving, combined with the greater aircraft sortie capacity and increased resilience, makes the Ford a long-term strategic investment, despite the initial cost of $13 billion for the lead ship being a point of controversy. The high price is the cost of innovation and the transition to a new generation of technology that will ensure naval superiority for decades. The investment is justified by the need to maintain the technological advantage over adversaries who are rapidly modernizing their fleets, especially China and Russia. The U.S. Navy sees the Ford class as the only path to maintaining global power projection in the future. The construction challenges and initial delays are the price of the cutting edge. The Ford is the first of a new class, and the integration of entirely new technologies such as EMALS, AAG, and the new reactors always presents complex and expensive obstacles. These challenges, ranging from software and system integration issues to the crew's learning curve, are inherent in the introduction of quantum leap technology that has no precedent. However, the Navy is committed to solving these problems, as the Ford's success is vital to maintaining U.S. naval superiority in an increasingly competitive global scenario. The second ship of the class, the USS John F. Kennedy, has already incorporated lessons learned from the Ford, promising smoother system integration and a faster delivery schedule, demonstrating the Navy's learning curve. The experience with the Ford is accelerating the construction of subsequent ships. The USS Ford is more than a ship. It is a catalyst for innovation, a beacon for the future of naval warfare. Its technologies, EMALS, AAG, nuclear electric power, drone and AI integration, not only influence U.S. strategy, but will become the global standard. Its influence extends far beyond American borders, serving as a model for the development of future naval platforms worldwide. The ability to integrate and optimize these advanced technologies into a single platform is what gives the USS Ford its superiority and its ability to influence the way navies operate globally. It is a testament to the cutting-edge engineering and strategic vision that have made it the most advanced and influential aircraft carrier in the world. The Ford class represents the Navy's transition from a platform focused on manned aircraft to a center for the operations of unmanned aerial systems and directed energy weapons, ensuring the Navy's relevance in the next era of warfare. The USS Ford is a declaration of intent, a symbol of the U.S. commitment to maintaining its naval superiority and leading the way in technological innovation. It represents the future of naval warfare, where technology, adaptability, and readiness for the future are the pillars of maritime supremacy. The Ford is the standard by which all future aircraft carriers will be measured, and its legacy will continue to shape global naval doctrine for many decades. The next ship in the class, the USS Enterprise, is already under construction, solidifying the future of American power projection and ensuring the continuity of the Ford class. The Navy plans to build 10 ships of this class, ensuring the backbone of its aircraft carrier fleet until the end of the century. If you enjoyed our content, subscribe to the channel, like this video, and share it with your friends so more people can learn about the incredible history and future of the USS Gerald R. Ford. Your support helps us bring you more quality content. An often overlooked aspect of the Ford class is its logistics revolution. The ship's design includes an optimized hangar and flight deck layout to reduce the handling of materials and weapons. The electromagnetic weapon elevators, which we have already mentioned, are not just fast. They are designed to move ammunition more directly and safely from storage areas to the aircraft on the deck. This eliminates the need to move weapons through crew traffic areas, increasing safety and speed. The ship's refueling capability has also been enhanced. The Ford can receive fuel and supplies from support ships much faster than Nimitz-class ships, reducing the time of vulnerability during underway replenishment (RAS) operations. This logistical efficiency is crucial to maintaining the high aircraft sortie rate, as the ability to launch and recover aircraft is useless if there is no ammunition and fuel for them. Automation in the handling of weapons and supplies is a key factor in crew reduction, as fewer sailors are needed for dangerous and repetitive tasks. This allows the crew to focus on combat operations and the maintenance of complex systems. The Ford is, in essence, a war machine designed to operate with maximum sustainability and minimal disruption, a fundamental requirement for power projection over long distances and in high-threat environments. The USS Gerald R. Ford is not just a piece of military hardware. It is a foreign policy tool. Its deployment sends a clear signal about U.S. interests and determination. In a world where maritime power remains the primary means of global force projection, the ability to have a state-of-the-art aircraft carrier operating in any ocean is invaluable. The Ford class is the pillar of the U.S. defense strategy for the 21st century, ensuring freedom of navigation and the deterrence of adversaries. The ability to integrate the current air wing, FA-18, F-35C, Growler, Hawkeye, with future unmanned systems and directed energy weapons ensures that the Ford remains the most versatile and lethal platform in the world. The Ford is the U.S. response to the naval modernization of powers like China, which is heavily investing in its own aircraft carriers and anti-ship missiles. By building the Ford, the U.S. is reaffirming its naval dominance and investing in a platform that can resist and prevail against the most advanced threats. The future of naval warfare is electric, digital, and automated, and the USS Gerald R. Ford is the first ship to fully embody this vision. The backbone of the Ford Revolution is its power generation capability. The two A1B reactors are capable of generating more than 250% of the electrical capacity of the Nimitz-class reactors. This power reserve is the key to the future. It not only powers EMALS and AAG, but also prepares the ship for the integration of directed energy weapons, such as high-power lasers, which require massive amounts of electricity to operate. The U.S. Navy plans to equip the Ford class with these defense systems in the future, offering a new layer of protection against anti-ship missiles and drones. This plug-and-play capability for future weapons ensures that the USS Gerald R. Ford is not just the aircraft carrier of the present, but the combat platform of the future, capable of evolving with technology and maintaining U.S. superiority at sea for decades. The digitization of the USS Gerald R. Ford extends to crew maintenance and training. The ship was designed with an emphasis on ease of maintenance, using a condition monitoring system that tracks the performance of thousands of components in real time. This allows the crew to perform predictive maintenance, correcting problems before they cause operational failures, which reduces downtime and long-term repair costs. Furthermore, the ship's design was entirely modeled in 3D, which facilitates crew training. Sailors can use virtual and augmented reality simulations to familiarize themselves with the ship's complex systems before embarking, reducing the learning curve and increasing operational readiness. The Navy estimates that predictive maintenance and improved design will reduce the maintenance workload by up to 10% compared to the Nimitz class. The combination of greater operational capacity and lower life cycle cost is what makes the Ford the inevitable choice for the future of the U.S. Navy. Although the initial cost of the USS Gerald R. Ford was approximately $13 billion, it is crucial to understand the strategic value of this investment. The cost is divided between the ship itself and the development of new technologies, EMALS, AAG, A1B reactors. Subsequent ships, such as the USS John F. Kennedy and the USS Enterprise, will have significantly lower construction costs, as research and development costs will no longer apply. The Ford's true value lies in its deterrence capability and its 50-year lifespan. The operational savings of $5 to $6 billion over its lifespan, due to reduced crew and more efficient maintenance, largely offset the initial cost. In terms of combat power, the Ford offers a capability that no other aircraft carrier in the world can match. It is an irreplaceable asset in U.S. defense strategy, ensuring that the country can project air power anywhere on the planet, at any time, with unprecedented efficiency and lethality. The Ford is not just a ship, it is a platform for global sovereignty. The combat capability of the USS Gerald R. Ford is defined by its air wing, which is constantly evolving. The Ford is designed to operate with a mix of manned and unmanned aircraft. It currently houses what the Navy calls the Air Wing of the Future, which includes the stealth F-35C Lightning II fighters, FA-18EF Super Hornets, EA-18G Growler electronic warfare aircraft, and E-2D Hawkeye early warning aircraft. However, the true quantum leap will come with the full integration of unmanned aerial systems, UAS. The MQ-25 Stingray, an aerial refueling drone, will be the first fixed-wing UAS to operate from the Ford, dramatically extending the strike range of the fighters. The EMALS's ability to launch lighter aircraft and the AAG's ability to recover them smoothly are essential for operating a variety of drones. The Ford is the first aircraft carrier to be designed to have a predominantly robotic air wing in the future, transforming it into a command and control platform for a fleet of combat and reconnaissance drones. This flexibility is the guarantee that the Ford will remain at the forefront of naval warfare throughout its life cycle.